Thank you for joining, everybody. My name is Jonathan Asher. I'm going to talk to you today about generative design for modular construction. Uh, First part of the presentation is going to focus on some of the industry trends that we see, and then the second part of the presentation is going to highlight the technical solution that we deliver through CATIA for this unique and transformational approach to project delivery. For those who don't know Dassault Systems, we are a large company focused on a number of different industries, but our primary purpose is to harmonize product, nature, and life, and to deliver 3D experience universes to imagine sustainable innovations to the world, bringing products to life and optimizing the human environment. I'm going to talk today about CATIA and the way CATIA shapes the world we live in. For construction cities and territories, which is one of the industry focuses from Dassault Systems, we are addressing this by bringing new buildings, new infrastructure, new city experiences to the world. And a number of our customers around the world are doing this every day on the 3D Experience platform. Today, within the industry, there's challenges everywhere. A lot of what is happening is the industry is focused on drawings and project delivery on a 2D with 2D documents. It's how it's been in the past. It's how it is today, regardless of what we'd like to be happening. Where architects, engineers, contractors, and operators are all working with their own set of drawings. They're not integrated. There's lots of, of, of overlap, and there's poor scope definition, and this all leads to project inefficiencies. Because of this, the construction industry has lagged in productivity gains over the past 20, 30 years, as the manufacturing industry has really engaged, really taken advantage of the gains that you can make with automation and a 3D design process. The construction industry hasn't made that leap, and so there's a desire now, and there's a motivation to move into a more manufacturing-centric approach for construction, so that we can recoup those gains and start to make more progress. And so the challenge now is to go from what I would claim the current state of construction, which is still in the very first industrial revolution of mechanization, through mass production into computer automation and eventually into cyber physical systems, where the entire chain of construction, the entire chain of fabrication, assembly, installation can follow an automated path. And CATIA has led this transformation in other industries. We've seen that in 1981, we brought 3D design to the aerospace industry, while most architects and engineers were still drafting in 2D. And over the course of time, we've continued to deliver innovations to these industries, and the architecture, engineering, construction industry is trying piece by piece, or has made piecemeal improvements over time, but those remain very outlier examples. And where we're going now into the future is to say that it's time to make that leap. It's time to make that leap the way the aerospace industry made the leap, the way the automotive industry made the leap. And we're proposing to go beyond what is the current paradigm of building information modeling into the future paradigm of building experience modeling for manufacturing, where through the use of parametric design, through the use of generative design, through the use of template capture and reuse, we're going to bring the efficiencies found in the manufacturing processes to a more construction focused to the construction industry. So where do we see this going? The transition from BIM to BEM, going from fragmented processes, files and documents, manual reporting, 2D planning, into a platform-centric approach with a common data environment within the context of the city to maximize knowledge capture and reuse. And what's the difference between BIM and BEM? Well, BIM is it's a limited approach because it doesn't have the capacity to integrate a fully clarified systems view, an integrated systems view of a building component, of a building project. BIM, we have an operational view, we have maybe a functional view, but really the manufactured view, the organic view of all the different parts and pieces that go into making up that system is what's lacking in BIM. So with the power of the 3D Experience platform, that's where we see this integrated systems view being deployed. And because it's on the 3D Experience platform, it's available to everybody, sharing the one common data model and one collaborative environment. That data model for us, for the construction industry, is IFC. It is interoperable. It functions across all of our applications, and it's able to then deliver that industry specificity to the construction industry on the 3D Experience platform. So the CATIA specifically, we have a portfolio of roles, and those roles are focused on delivering a continuous level of development so that designers who don't need a high level of detail can be working in a conceptual model, but that model can be directly linked with the manufactured components and the highly detailed models that include all the information required for fabrication with the click of a button. And we have two focuses, one on buildings, one on infrastructure. Today I'm going to focus mostly on buildings, but I suggest if you'd like more information about our solutions for infrastructure to reach out and we can provide any information that you'd like. So just quickly, an overview of the role portfolio because it's changed from the last 2 months. What you see here is the new 21X role portfolio. Prior to this, it was similar but slightly different. And so we have roles are commercial packages of applications. So it's what a user buys, it's what a user uses to deliver a construction project. And we have a portfolio of roles that go from architecture and buildings to infrastructure for roads and rails and civil infrastructure projects. Excuse me. And a dedicated portion for systems, mechanical, electrical, plumbing, and fire, and coordination and presentation. These roles are then grouped to deliver processes. These processes are something that a department within a company are going to do, and those processes then make up what we call an industry solution experience. This is a look at creative building design and the processes and roles within that solution: civil infrastructure engineering, integrated built environment, and then the global portfolio of industry solution experiences for the construction cities and territories industry in 2020. We're going to focus on design for fabrication as we look in how and why we're delivering generative design for modular construction. In this case, we're going to look at a partnership that was signed recently with AIDEN. AIDEN is a facilities management group, a global facilities management group that's headquartered in Shanghai. And we're working with them to develop something called a KillaCare, which is an innovative solution to deliver turnkey construction projects. And what we're going to show here is the result of course, the COVID crisis and how the urgent need for hospital beds in China has pushed the construction industry, pushed AIDEN to develop this system to deliver smart and connected hospital beds. What I'm going to show here is really the proof of concept that kicked it all off and led us down the path to develop this system, which is going to go beyond and then the COVID crisis. It's going to extend into other countries and around the world to deliver not just hospitals, but other projects, other construction projects for all different kinds of uses. And so the business benefits here is to, of course, reduce delivery time, to reduce errors and costs, to meet the local government standards, to optimize the human environment and to maximize operational efficiencies. So what I mean by optimize the human environment is to do air simulation to make sure that the spaces that are being created are going to be optimal for a hospital environment. Maximize operational efficiencies, well, that's to make sure that the operations of the building will run smoothly once it's been completed and delivered, and it's going to fulfill the need that it was originally intended for. And so that being said, we'll get into the details of what that looks like and how we match our generative design solution to a fabrication manufacturing solution on the 3D Experience platform. So this is Generative design, and I'm sorry, I'm running a video here. It's going to run for the next 10 minutes. I hope the screen comes through all right. I hope you're able to see what I'm presenting. But Generative design is a web application that runs on the 3D Experience dashboard. And here we've gone through and we've developed an intelligent generative algorithm to do space planning and to lay out hospital beds based on a site condition. So in this case, we have a site boundary. That's the maximum buildable site. We've laid out our units, and by manipulating the boundary conditions and a number of parameters that we've established as important driving parameters, we can modify the layout and see how the resulting spaces match the requirements for the project that we're going to be building. And so some examples of the parameters that we've decided to manipulate and to control our model, say the angle here. We have the offset, the maximum offset of the boundary. We have the different distribution of spaces. So what is the distribution of staff rooms versus medical rooms? And those the resulting attributes, then the resulting KPIs of each of our designs, each of our design variations, is being captured in the monitors tab. The monitors tab you saw flashing over on the right-hand side. That's an interactive and dynamic tab that is displaying information that's being computed in our model. And so that as we modify our design, that data is being pushed back and giving immediate feedback to the designer of what's happening. So that's the generative space planning aspect of this project, and it serves as a way to do an initial layout of the project and to see what is the design potential of a given site. But we don't end there because that model can be then brought into what we call the rich client. The rich client is the CATIA application that you download from the cloud. You install it on your local machine, so it's not running on the web anymore. But it's completely compatible. It's with any of the models that have been created in the web client, in the web app. So we've opened up our space planning model, our generative space planning model, and we're going to also open up a detailed hospital unit. So this is a unit that contains 2 beds and a central lavatory and washroom. This unit is inserted into our space planning model, and then it's constrained into place. So we're going to move this unit into place and then replicate that unit to all of our similar hospital units. So in this way, we're adding a level of detail. We're adding this intelligent and more detailed unit to our space planning model. Here we see it within its context, its first context. And now by assembly patterning this around the building, here we see a preview. That unit is replicated everywhere. And so now we have all of our units, all of our modules in place. And here at this point, we can pull off the bill of materials. We have the number of doors, number of beds. All of that information is accessible to us, and it remains generative. So as we go and we manipulate the boundary, our site boundaries now, we see that we're not just updating the space planning model, but we're also updating our our detailed units. And and so this is the link. This shows the link between a concept model and a more detailed model. But this isn't really enough because this component right here, we don't have enough information to really manufacture from it. We have a bill of material. We have a more detailed information about each space, but now we need to start to frame these walls and go into the manufacturing portion. So we have right here a generative wall component, a generative framed unit, and that wall component is composed of some cold formed studs, top and bottom tracks, some insulation panels, and then the drywall or whatever covering panel you like. We see that by modifying the parameters, we're updating that model. So it's a generative model. But what's really important to note is that it's also configurable. So by changing those one of these configuration settings, we can modify the parameters of all of these units. So with that, we're going to insert this detailed framed wall into our model here. And we do that by defining a specification. So we have a low level of detail wall, which is represented by a volume. By associating this wall template to those wall volumes, we're going to be able to very easily and quickly instantiate that detailed wall into this model and and from that wall model, we're going to extract the required information for fabrication. So again, all of those parameters and configuration settings are accessible through this specification. And when we come back to our context model, we can run what's called change level of development. Change level of development is now going to take that simple volumetric model of the wall, and it's going to insert the detailed component in place of that volume. So here you see we're going to instantiate those panels. Now the walls are being inserted into our model. In this case, we've inserted 8 walls, 4 for each of the sleeping areas of that hospital module. And there you see they've been inserted into the model, but as with most things in life, it's not quite right the first time. So we need to go back in here and modify the configuration that has been inserted into the model. You see that the alignment here is off. It's not centered on the wall. So we're going to go back into our change level of development command and synchronize the changes that we made. And now you see that those walls have been inserted correctly, or have been modified to sit flush within the center of the walls. And to show the power of the generative aspect of these walls, you saw the original wall didn't have any openings in it, but now these newly inserted walls have taken into account where the doors are, and they've updated their framing to match where those how to frame around those doors. And more than just that, each one of these these walls brings along with it a drawing that's used for assembly requirements, and again for bill of materials, and further to be used for fabrication. So when we run the update, we see here's the updated drawing for that wall. That includes all the information about each one of the units, each one of the parts and pieces. And an example of a wall with a door. You see we update this model and we have a couple of doors here. We've got the framing layout for that and a detailed bill of materials. So what's really exciting about this, and what's the true benefit of an approach like this, is that you're able to link a concept design with a detailed design, all in a seamless approach to go from a generative model to a fabrication model on the same platform with the same set of industry processes, all contributing to one solution. And we're really excited to see where this goes with Aiden and our Aquila project. So with that, I will end my presentation, and I'd be happy to answer any questions.